Okay, so now we will take algebra into the domain of inequalities. We've only dealt with algebra involving equality, so the equal sign, but now we'll be working with inequalities. The same general principle applies for inequalities as equalities. We're trying to isolate for x, or we're trying to see all the possible values in which x can take on. Let's start off with an example, and then we'll see the subtleties between algebraic equalities and algebraic inequalities. Now what we want to do is we want to try to get rid of all the numbers on the left-hand side. So we only want to get x isolated by itself, and we want to try to get only numbers on the other side. So our purpose is to isolate for x on one side and to isolate for numbers on the other side. This is very similar to algebraic equalities that we've done before. Let's do that. First thing we want to do is to get rid of the 3. What we'll do is we'll subtract 3 from both sides. Now we know that any number subtracted to itself is always 0. Two minus 3 is equals to -1. And we know that any number plus 0 is always that same number. Adding 0 does not change what that number is. Finally, we see that x is less than -1. Now just a quick little tip, if once you get better at this, you can maybe skip some of these intermediary steps and you can just quickly evaluate it like this. For me, I would just solve it this way. Starting from here at the beginning, I would just try to bring the 3 to the other side and then x on the other side, and I would have the following. So as you see, we have the same result, but we saved up some of the work that we had to do. Now, here is the subtlety for algebraic inequalities rather than equalities. When we had an algebraic equality, what happened was usually x could take on 1 or 2 different values. It could take on only a specific amount of values that would satisfy the expression. When we have an inequality, you can have many or infinite solutions. For example, x has to be any number less than -1. X could be -1,000, -100, -500, -501, -502. So it could be infinite possible numbers that would solve this inequality. Whereas if we had something like this, x is equals to -1, x can only be one possible value, that's -1. That's the only thing that will make this true. Whereas in this, you could have infinite answers that will make this statement true. We did an example involving addition, so inequalities involving addition. Let's do one quick one involving subtraction. We want to isolate for x on the left-hand side, and we want to try to get all the numbers on the right-hand side. So let's add a 5 to both sides. We have, and just to highlight something, what I'm doing is I'm putting the inequalities right underneath each other. It's kind of like a bookkeeping scheme, so I don't mix up what I'm doing. I can clearly see each step that I'm doing. We know that if we add if we have 5 plus its opposite, or negative 5 plus 5, this will always be equal to 0. So we have x plus 0 is less than what? That would be less than 4. Finally, we have x is less than 4. This is the result we're looking for. This says that if you take any value less than 4 and you plug it into this inequality, this will be true. Let's take one arbitrary value and see if that's true. Let's take 3. So we'll take 3 and we'll plug it in. We'll do that here. Let x be 3, so 3 minus 5 is 3 minus 5 less than negative 1? Well, 3 minus 5 is negative 2. That is indeed less than negative 1. Just to recap, the subtleties between an algebraic inequality and an algebraic equality is when you're dealing with equalities, you only have you only have a specific amount of possible values x can take on. Rather, when you're dealing with an inequality, you can have an infinite number of values which make the algebraic expression true or false.